Hi everyone, it's Sorkin. Today we have a problem when we are given an array of integers which represents piles, and Alice and Bob is playing a game. So at each iteration, Alice starts first. Alice or Bob takes the one pile of stones either from the beginning or from the end. So let's say that Alice starts from the end, and Alice takes 5. Then Bob takes, let's say, also 5, and then Alice takes 4, and now Alice has 9 stones and the Bob has 8 stones, so Alice wins. So we need to return true if Alice wins or false otherwise. So another important requirement is that there are even number of piles, and also the total number of stones across all piles is odd. So it means that someone should win, either Alice or Bob. Let's take an example where we have only 3 stones, and we are going to solve this problem using dynamic programming bottom-up approach. So what's the idea behind dynamic programming bottom-up approach? The idea is that we are taking a problem and we are splitting that problem into sub-problems, and we are first solving a sub-problem, then we are building up to our solution. So let's take this scenario, right? Let's say that we have only 2 stones, not 3, but we have only 2 stones. For Alice to win, Alice should start from the first, right? Alice picks 5, and then Bob's picks 3, so the difference is 2. Alice wins, right? Let's say that we have these 2 stones, right? These 2 stones, again, Alice starts with 4, and Bob starts with Alice takes 4 and Bob takes 3, so the difference is 1. Alice has 1 more stone, 1, right? Alice wins. And let's add that. Let's add that to this scenario, right? To 5, 3. Let's say that we are adding 1 more to the right. So, and Alice starts with the 4. If Alice starts with the 4, with this case, right? So if Alice starts with the 4, so it means that the Bob, again, every player plays optimally, right? So Bob also will take 5. So Bob also will play optimally. So if Alice takes 4, so what would be the difference? The difference between these two is 4 and 2. It gives us what? It gives us 2, right? The difference 4 minus 2 gives us 2. And again, for this scenario, right, the maximum is 1. If let's say that the Alice we are adding 1 more element to the left, and the Alice starts from here, so 5. If Alice takes 5, right, then the Bob also will play optimally. Bob will have 1, right, because Alice starts from here. And the Alice takes 5. 5 minus 1 gives us what? Gives us 4. And it doesn't matter from either side we start, from the left or from the right. If we start from the right, if we start from the left, we are ending up with the 4 stones, right? If we are starting from the left, we end up with the 2 stones, and we are taking the maximum of it. It is 4, which means that we are returning true. Alice will win. So, and again, we used here dynamic programming. We split our problem to sub-problem. First, we solved our sub-problem, then we build up to our solution. So how we are going to do that in terms of the two-dimensional array? So for example, in this case, if we have only from 1 to 1, right, from index 0 to 0, let's say this is index 0, 1, and 2, right? So for each index, if we start from the 0 to 0, from the index 0 to 0, the value is 5. From index 1 to 1, if the 1 stones, Alice starts first and Alice wins. So we have 1, and we have 4 from 2 to 2. So from 2 to 2, right? And now let's go to from 0 to 1. We solved this sub-problem, right? What is the sub-problem here? The sub-problem is that we are taking the maximum, and the value is from 0 to 1. In this case is what? From 0 to 1, value is 2. How about from the 1 to 2? We solved also this sub-problem from index 1 and 2. From index 1 to 2 is what? is 1, right? Now we solve this subproblem. We solve the subproblem of 0, 1, and we solve the subproblem of 1 and 2. Now let's solve the problem 0 and the 2. 0 and the 2 is our whole array, right? And what if the result is positive, which means that the Alice can win. If the result is negative, then it means that the Alice cannot win and we are returning false. So in this case, the maximum here is 4, but let's put the formula for it. The formula for it that we are going to choose that the maximum of at each step, right? So we are taking from our piles, and let's say that this is index, this is I index here. For the beginning, it's an I index, and for the end, it's a J index, right? I and the J index. So what we are doing in this case, we are taking that the piles, so we are taking here piles I minus what? So for example, in this scenario, right, when our I is equals to 0, right? So for the 5 minus what? 5 minus 4 gives us 5 minus 1 gives us 4, right? So which means that the 5 minus from index to 1, again we solve this problem, which means that the pile 0 minus from 1 to 2, so from 1 to 2, right? So from 1 to 2, what's the value from 1 to 2? From 1 to 2 value is 1. So it means that we are taking dp, we are taking I plus 1, I is 0, right? I plus 1, I plus 1, I plus 1, and j, right? So we are taking when we are considering leftmost element. When we are considering rightmost element, which means that the j, right, piles j, then piles j minus dp, so we are taking I and the j minus 1. What is the dpj is equals to 4, and the dpi j minus 1 is what? Is from 0 to 1, right? From 0 to 1, the value is 2. So we are taking the maximum of these two cases. In our case, the first one is 4, and the second one, the value for the second one is 2, right? 2. And we are taking the maximum, which is 4. And at the end, we are checking that if this value, right? If this value from 0 to the length of our input array, if that is positive, then we are returning true, and if that is negative, then we are returning false. As you can see, what we did here, we took our problem, we split our problem to subproblems, then we solve first subproblem, and then we build up to our solution. Again, let's say that in our case it goes with the increment 2. We have like a 5, 3, 4, and let's say 5, right? So in this case, again, we will solve first these two subproblems, and this subproblem. Then we are going to build up this subproblem for this 3, and then at the end we are going to return for these 4 elements, right? So again, we are starting with the subproblem when we are first solving for the 2 elements, then we are solving for the 3 elements, then at the end we are returning whatever result whatever maximum we are getting for 4 elements. If that is positive, we are returning true, otherwise we are returning false. Okay, first thing that we do here, we are creating a 2-dimensional array dp where we are going to store our results. And also for when the I is equals to 0 or 1, 2, 3, for example, from the index 0 to 0, from index 1 to 1, as we have seen earlier, we are just setting the pile, whatever the pile is. So let's say that if we have only 1, we have odd number, then in that case, Alice wins, right? So 5, 4, 3, and so on, we are setting to dp values. The next one is that we are going and populating our 2-dimensional array. We are going with the increment 2, and for each iteration, we are selecting our I and the j. So j starts with from the end of our, so whatever the k is, I plus k, so I starts from the beginning and the j starts from the end of the array. And then we are, so for that case, we are for each iteration, right, that as we have seen earlier, what we do, we are populating for I and the j, we are taking whatever the maximum of I minus I plus 1 j, and or whatever the piles j minus I j minus 1. And at the end, we are returning our result as 0 and the n minus 1. If the last element in our first row, which means that our result, if it is more than 0, it means that Alice has positive number of stones and Alice wins. Otherwise, we are returning false. The time complexity of this solution is n squared because we have 4 and 4 loop here, and that determines our time complexity. Our space complexity is determined by the two-dimensional array. It's also n squared. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.